Hello friends, I am Apoorva Gupta, Assistant Professor in B.IIET International Institute of Engineering Technology in Department of Electrical Engineering. Today I am here to deliver a lecture on thyristors. Thyristor is basically the most atomic switching unit of different power electronic devices like choppers, rectifiers, inverters and cycloconverters. It is basically a 4-layer, 3-terminal, 3-junction device. And its working is basically divided into 3 modes: reverse blocking modes, forward blocking modes and forward conduction modes. First of all, I'll explain you all what is reverse blocking mode. In the reverse blocking mode, the reverse power supply is provided to the 2 terminals of the thyristor. This is a anode, this is a cathode and this is a gate terminal. In the reverse blocking mode, we will provide the reverse supply to the thyristor. Reverse supply means anode terminal is provided with negative supply terminal and cathode is provided with positive supply terminal. Now let's see what happens with this kind of supply. Now look, P junction is connected to negative terminal of the supply and the N junction is connected to positive terminal of the supply from downwards. In junction J1, P is connected to negative, N is connected to positive terminal supply, which makes this junction J1 as reverse bias. Junction J1 is reverse bias. Make a note over here. Reverse bias. Now look at junction J3. P terminal is connected to negative supply and N terminal is connected to positive supply, which makes again this junction J3 as reverse bias, as P is connected to negative and N is connected to positive. Now junction J3 is same, reverse bias. Now look over here at junction J2. N is connected to negative terminal, P is connected to positive terminal. This makes this junction J2 as forward bias. Now junction J2 is the sole junction which is forward biased. So in the reverse blocking mode, we have junction J1 and J3 as reverse bias, while junction J2 is forward bias. But for the proper conduction through this thyristor layers, we need all the 3 junctions to be forwardly conducting. So the reverse blocking mode gives the reverse region of the VI characteristics of the thyristor. Look over here. You increase the voltage level, but current is increasing a little bit. Increasing the voltage to a great extent will give a minute rise in current, but after the reverse breakdown voltage, there is a steep rise in current which can damage this device. So reverse blocking mode is not suitable for the working of thyristor. Now we will move to second mode, forward blocking mode. In the forward blocking modes, what we do, we provide the forward supply to the anode and cathode terminal of the thyristor. Forward supply means anode is provided with positive terminal of the supply and cathode is provided with negative terminal of the supply. Now look what happens to the working. P is connected to positive terminal of the supply, N is connected to negative terminal of the supply, which gives junction J1 to forward bias region. Junction J1 in this mode is forward, as P is connected to positive and N is connected to negative. Now look over junction J3. P is connected to positive terminal, N is connected to negative terminal, which brings it into forward conduction, forward. But junction J2, N is connected to positive terminal, P is connected to negative terminal, which brings this junction J2 into reverse region. And as I told you earlier, for the proper conduction, all the 3 layers are required to be forward biased. But in the forward blocking mode, we again have only 2 layers as forward, but the junction J2 is in reverse, which gives basically the forward blocking mode characteristics of the VI graph, this region. Now let's move to the third and the last mode of the working, forward conduction mode. In the forward conduction mode, the supply terminals are kept as same as in the forward blocking mode, but what we do is we provide a gate triggering to break this junction J2. Junction J2 was reverse biased for the forward blocking mode, but when you provide gate triggering to junction J2, then it externally or forcefully breaks this junction J2 and brings it into forward conduction mode. Now when the sufficient gate triggering is provided, this junction J2 comes into forward conduction mode, and basically all the 3 junctions which we required for the proper conductions are now in forward conduction mode, and the proper forward conduction mode can be shown in this VI characteristics with this line graph. We see this a small or minute rise in voltage brings a major rise in current. This is basically what is known as forward conduction mode. Now this completes the working of Thyristor. Thank you, and thank you. For any queries and detailed examples, log on to www.grookpu.com. Thank you.